We're given a Venn diagram with four events A, B, C, and D. And we're asked to write down any pair that are mutually exclusive. So mutually exclusive is when two events cannot happen at the same time. And on a Venn diagram, it's where there's no overlap. So I just went with A and C. You could also have said D and C or B and D. So those are the three options. It's now given that the probability of B is equal to 0.4, find the value of P. So the probability of B is all of these probabilities added together. And therefore, we're going to have 0.31 coming from the 0.24 plus 0.07 plus P equals 0.4. And therefore, P is going to equal 0.09. Given also that A and B are independent, find the value of Q. So because they're independent, that must mean that the probability of the intersection of A and B is equal to the probability of A times the probability of B. This is a result that follows on from conditional probability, in fact, but we can use it here. So the probability of the intersection is actually that 0.24. That's going to equal the probability of A, which is 0.4 plus Q, multiplied by the probability of B, which remember we know is 0.4. If I divide through by 0.4, I'll get 0.4 plus Q equaling 0.6. So Q is going to equal 0.2. Now we're also told that the probability of not B given C is equal to 0.64. And we're asked to find R and S. So this is the last part of the question. So for conditional probability, the probability of A given B, this is just now general events, is equal to the probability of the intersection of A and B divided by the probability of B. Because what we're actually doing is we're saying, right, we want the probability of this happening given that this happened. So we're scaling the probability because none of this would have happened anymore. This is a general idea. Of course, in our case, we're looking at not B given C, but it's still going to work. So we can write down that the probability of not B intersected with C divided by the probability of C is equal to 0.64. Right, not B intersected with C. That is just going to be R by itself because we need it to be in C and not in B. So R divided by, remember we've worked out P, didn't add it on before, but it was 0.09. And I also worked out Q, just write that there, 0.2. So R divided by R plus 0.09 is equal to 0.64. Got ourselves a little equation to solve. We're going to multiply through. So R is going to equal 0.64R plus, then we need to do 0.64 times 0.09. This ends up being 0.0576 minus the 0.64R. So 0.36R is equal to 0.0576. And then R ends up being 0.16. And finally, for S, well, we know that the sum of all the probabilities in the Venn diagram must be equal to 1. So if you just add them all up and minus from 1, add them all up apart from S, minus from 1, you will manage to get S, and it ends up being 0.08. Great.